Welcome back. Today we are going to solve Leetcode question number 978. The question is like longest turbulent subarray. So let's try to understand the description first before jumping into the solution part. So the question states, given an integer array ARR, return the length of the maximum size turbulent subarray of ARR. A subarray is turbulent if the comparison sign flips between each adjacent pair of the element in the subarray. So, more formally, a subarray of ARR is said to be turbulent if ARR of k is greater than ARR of k plus 1 or ARR of k is less than k of plus 1 when k is even. Okay, so, okay. So, or for k is less than j, ARR of k is greater than ARR of k plus 1 and ARR of k when is odd. So, uh, it is pretty much like I think like it should be either like 1, sorry, 10, 20, 9, 18, like this kind of process should be there. So basically we need to check like the is it like in a zigzag pattern, like what I can understand, like either it should be like first one should be greater than, then next one should be smaller than. So like this kind of process should be there. Let's try to understand it with the example. So yeah, 9 4 2 10 7 8 8 1 9. So here it states that this is the longest. Yeah, it's pretty much clear with the example here, like this one is bigger, then this one is smaller, then this one is bigger, then this one is small, then this one is bigger. Okay, so let's try to get into the constraint. Okay, yeah. So constraint is 4 into 10 raised to power 4, which pretty much assure us that we can go for of n square time complexity, and we will not get TLE even if we use of n square time complexity. So yeah. So let's now try to figure out like how can we approach this problem. So mm, I am thinking like, can we have like any mm, okay, so I'm thinking of like, can we not go in like greedy way? Like we can have like, if that was bigger or smaller, like where can we go wrong in that kind of thing? Like this is 4 at 12. So, so if this element is there, then we want to take the smaller one, right? So that is how I am thinking. Like for each element, we can check like what is the till where the turbulence is there or not. So I think that process will be good. Like for each element I'm trying, and I'm trying to see like whether turbulence is there or not. And even if it is there, then how much big it is. So and since we can go for of n square time complexity, it looks feasible to go with that kind of solution. Should we hit that kind of solution? I'm not pretty sure. So yeah, let's give it a try once. So yeah, we just made an we are just iterating an array, and I just defined n is equal to arrow dot size. Now let's take mx turbulence, int mx turbulence is equal to 0 for now. So I think we can have like one is the mx, like right. If just error of one is there, it will correspond to one. Yeah, here it is pretty much the same. So yeah, and if uh, n is equal to zero, we need to return simply zero. So yeah, n can be zero as it is mentioned here. We can see. Okay, no, no, sorry, sorry. The length can be only bigger than one. Okay, so we don't need this condition here. So that is pretty much we are done with this thing now. um, mx underscore tul will be equal to get get turbulence, and let's have like index I, and let's have an array arr. Okay. So now let's have like function here get turbulence. Okay. Now we have like int idx for that index which we are searching for. Let's pass vector int ampersand arr. So yeah, so this is also done. Now let's try to get the turbulence. So uh, one observation for me is like if the 2 is the part of this turbulence, let's say like 4, 2, 7, 8, this part. So if 2 is part, so we don't need to again go and do for the 2 here, right? Like it won't make sense to have like count of turbulence till here. We can directly start from this 8. So this way we can actually reduce the computation. So yeah, I think that way it will be pretty cool. So let's go that way only. So like first let's get the count. So int count is equal to 1. And let's have your max turbulence is equal to max of mx turb, comma mx get turbulence of I comma a array. Okay, now int count is there. Now like we are starting from int I is equal to idx plus 1. uh, int idx is equal to plus 1 and I is less than arr dot size I plus plus. So now what I was thinking was like we need to follow the zigzag pattern. So to make a zigzag pattern, we need to have a switch basically, like it follows the switch, right? So I need to be sure like the next element is greater or bigger. I need to be figuring out like that. So like what I'm trying to say is like here it can be 9, 10, and 4. So since here it is small, so next one need to be bigger. So we will have like bull next and next bigger. Okay, which is which will be defined here. Okay, if so, I think we will need to compare from here. So wait, if nums of I, okay, if nums of idx is greater than nums of idx plus 1, so this means that if it is equal to nums of idx plus 1, we need to simply return here 1. Okay, now if nums of idx is greater than nums of idx plus 1, so we will have like and there will be a condition like else here, else, we can put here else if simplify it, and we can have here else part. So I think how we are going to know like next one should be smaller and the loop is knowing that it is moving in a zigzag pattern. That is what I was thinking. So we need basically a switch. Okay, so let's have here like bool big, next big, next big. Okay, so if it is here like next big, so this one will take care like if next one is big or not. So here we can see that since nums of idx is bigger, so next big is false, and next big is equal to. So we got to know like this element is a 9. So now the 4 comes. Okay. So 4 comes. We are pretty sure like this is we will start from idx plus 1. Uh, okay. We are going to start from idx plus 1 and okay, wait. We can have int count here. Let's have count as 1. Okay. So if count is equal to 1, let's have false. Bool next big. So this will take care of next big. If count is equal to 1, we need to perform if let's have I as I plus 1. And let's have previous element also here. I. So previous element is ARR of I. So we can have like int previous element. So this one will give if previous element is greater than, if previous element is greater than so this count part, yeah, if previous element is greater than error of I, okay, and if previous element is greater than error of I, then previous element is lesser than error of I, else. Okay, so here what we will get is get turbulence, turbulence. Okay, previous element will become error of idx, idx will become idx plus 1, error. Okay, count will be plus 1, and next big we need to check if it is a next big or not. So to check it is a next big or not, I think probably we will be needing like so this element is smaller, this one is bigger, so next element should not be bigger, so we can have like false here. Similarly here we will have the same concept, and just we will have like this one was smaller, next one should be bigger than previous element. Okay, so this is for this. If okay, we can have like okay, we can return one here only. I think we don't need count here. I think so. mm, we don't need count here. So yeah, now return one plus. I think similarly return one plus. I think okay. We will need count basically. Yeah. Okay. Uh, let's see to that later on. If next big is true, okay, next element should be big. And how we are checking the next big, like we are at this previous element. If array of idx is bigger than okay, if idx is less than previous element, then this is not valid case, right? Return zero. We need to return zero. Else return one plus get turbulence of okay, get turbulence of one plus not next big, so that another one gets smaller. Else next one should have been smaller, but it is greater. So we are doing this thing. Okay. So now we need to take care of this recursion what we have written. So what I am thinking here is like okay, if ARR of idx, which will be always true. I don't think so. Yeah. Okay, let's have count is equal to 1, and let's not count here. Let's skip it count. Let's skip it count. Let's skip it count. And let's skip it count. Yeah. Return 1 plus, and similarly here return 1 plus. I think. Yeah. And similarly return 1 plus. Okay. So I think we are pretty good till here. And as soon as we hit uh, if idx is greater than equal to ARR dot size, we need to return again 0. Okay, so yeah, I think this is good. So anyway, it will go in one flow according to me. Like it won't have two branches. I think it will have only one branch. So yeah, I think that way this should move. And let's try to run it once. Okay, there's some disturbance. I think. Okay, turbulence. Sorry. Okay, I think we have wrote the function incorrect. Okay. Okay. So let's try to print the value and see like what is getting into this get turbulence and what count we are getting. Okay. So yeah, we will be printing. Okay, let's first get like, is it going through the right pattern or not? See out previous element. Perfect. Let's try to print it. Okay. My God, it printed everything. I think so. So 942 should not have been there. So we are missing something, I think. Okay. 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 Again, printing whole array, I think. Yeah, it's printing whole array, but it should have printed 4 to 10, I think. Okay. So it's increasing, decreasing, and increasing, increasing, increasing. I don't know what is happening here. So, uh, okay, let's try to print uh, ARR of IDX, and at the same time, let's try to print next week. Okay, I think this will not work. Here also. So 4 is there, 2 is there. Uh, so we set like next pick is false starting. Yeah, perfect. Now 2 is there and 10 is there. So here next pick is equal to true was there. So if next pick was there, we probably went inside this out past slash n. So I think we straight away went inside that one. So 2 is there, 10 is there, it passed. So, oh, 1 minute, where did the 9 go? I think 9 was also there. Oh, now it's working correct, I think. It should not have worked for 8, 8, right? So, we need to make here the change that if error of idx is equal to previous element. Anyways, like, I'm not getting like why it went for 8, 8. It should not have gone for 8, 8, right? So here, if array of idx is equal to this, greater than equal to 8, right? Yeah, now it will not go. So I think we got here our okay 4, 2, 8. Hi, that's correct. I think that was the need of the hour. Yeah, so we got like this one. So now let's try to print this thing. Let's comment this out. Let's comment this out, and let's try to print the mxtur value, mxtur value, and see if we are getting the correct one. And then okay, we are getting 5, 5, 5, 5, 5, 5. Correct. For case 2, we are getting 1, 1, 1. Okay, so why are we getting 1 here is the question now. So, and why are we getting 5 there is the question. the next question. Yeah. So what is happening here is like it is going here. Now here previous element is less than this value. Okay, less than the 8. So what is happening? It is getting called here. One is less than this, and to whichever position it goes, I think it will go to next. Since here next big was there, then it shouldn't be not next big. Else condition it will go. And since 12 is bigger, I think it is returning 1 because only 2 of this is getting matched. So now why here we are getting this extra is now since 4 comma 2 is there, now 4 is greater than 2. Okay, now we compare 2 comma 10, again a 1. So now again 10 7, again a 1, and then 7 8, again a 1. So I think this should have also returned 4, but I'm not sure like why it returned. So let's check once again. 4 2, yeah. Now 2 10, yeah. 10 7, yeah. And 7 8. So yeah, this should have also returned 4. I'm not pretty sure like why it returned this thing. Let's try to print here previous element. Like I've been missing something. Yeah. Okay. So still it is lower. Okay. Okay. I got it. So since previous element was less than array of index, we need to pass it here. Uh, next element should be I think okay we made a mistake here I think. So since 9 is less than 4, previous element is less than 4. Like let's take an example to understand it better. Like 1 is there, 4 is there, 1 is less than 4. So next element should be bigger, right? True. But it should be false and this should be true, I think. Let's try to run it once. Okay, that should be false and this should be true. Okay, we are again getting this value. So I'm not getting like why we are getting this value here. Even though if I have hard coded it. So let's see like if previous element is smaller and this value is bigger, like 1 4 is there. Next element needs to be smaller, right? So next big should be false here and this should be true. Yeah. So we got like 9 4 1. Yeah, this is correct. 4 to 7, 10 7 8 4. Yeah, I think this should work. And let's try to return max mx turbulence and see. Okay. Okay. So okay, yeah. So we will have 1 plus this. Okay. Run. Let's try to submit it. Okay. We got a wrong answer here, saying that 1 comma 9 comma 9 is not a possible valid answer. So why it is not a valid answer, we need to figure it out. So if okay, okay. So here we missed that statement, else if previous element is an ARR of IDX to perform this element, else return 0. Let's use this test case. Okay, we ended up getting again a wrong answer. I think output is 11, way too much high compared to this thing. So let's try like where we did we fail here. See out mx star mx underscore. Okay, use this test case. Let's use this test case and try to run. Okay, so we have max stub here 8. Okay, we are getting here 8. So is this maximum increasing down increasing equal to. So somewhere we are having like equal to and we are filling. So I need to see like where is that. So let's make that very clear at above only. Like if ARR of ID x is equal to previous element, let's return 0 directly here. Now let's try to run this one again. Rather than writing continuously this condition, let's have it there. So let's try to submit it again. Okay, we got TLE now. I think somewhere we are printing something. Okay, let's have that thing now. So, okay, so, okay, let's remove this one also. Let's try it again running it. Okay, we are again getting TLE. So again we are printing something, I think. Yeah, we are printing. Okay, yeah, so now that is accepted. So yeah, I think that TLE was basically due to this reason only, like we were having cout statement. So yeah, that's all from my side. Okay, thank you. Yeah, bye.